Hello guys, so today we'll be doing question 155 of LeetCode, which is minStack. The question is, design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Implement the minStack class. So minStack initializes the stack object. Void push int val pushes the element val into the stack. Void pop removes the element on top of the stack. Integer top gets the top element of the stack, and integer getMin retrieves the minimum element in the stack. You must implement a solution with O one-time complexity for each function. Example, input 1, minStack, push, getMin, pop, top, getMin. So returns nothing, returns -2, returns 0, returns -3, returns nothing. Output null, -3, null, 0, -2. Okay, so this pushes -2, this pushes 0, this pushes -3. And these are the return values. So minStack, new minStack push -2, minStack push 0, minStack push -3, minStack getMin return -3, minStack pop. Okay, so the way we would do this is inside the class minStack, we'll initiate a variable stack and a variable minStack which contains the elements in order from largest to smallest. And then here we just push it in both. And push in the smallest one, push it in order of largest to smallest. In pop, we return the top value from the stack. We remove top value from the stack and minStack. Here, we return the top value from the stack, and getMin return the last value from the minStack, which pretty much is the smallest element. So let me show you how we would do this as an example. So just open the whiteboard. So let's say, well, I don't have to show an example, I'll just walk through the code pretty much. So here, we initiate a stack. So this.stack is equal to empty array. We do the same for minStack, which is an empty array. And as you can see here, returns nothing, but it passes a number value as a parameter. So we have to push it into the stack, and we have to push it into minimum stack in smallest order. So what we do is, we just push it into the stack immediately. So stack dot, we do this dot stack to reference the class's value. This dot stack dot push, we push the value, and then we have to check if the last value of minStack is smaller, and then we push it to the end. Otherwise, we push the last value to the end, so we keep the same length. And otherwise, if the minStack is empty, we also push it. So we'll do if this dot minStack dot length is equal to 0, or this dot minStack, so we get the last value by getting minStack dot length -1. So if this is bigger than the value, then we know the current value is smaller, so we push it to the end. So this dot minStack push value. Else, we need to keep the length the same. So push into minStack the smallest value, which will be the current number at the end. So this dot minStack dot push, this dot minStack, and then we get the minStack dot length -1. Okay. The next one is a pop function, so just remove top value and returns nothing. So remove top value from both. So this dot stack dot pop and this dot minStack dot pop. And top function returns the top value. So what we have to do is just return the stack length -1. So this dot stack, and we get this dot stack dot length -1, which returns the last value, and I get min. So from here, we just do the same, but for the minStack. So we return, we have to return this as well. I forgot that returns the number. Here we return number as well. So return this dot minStack dot length. No, this dot minStack, and then we get this dot minStack dot length -1. Now let's check if it passes. This dot minStack. Okay, I didn't define here. We have to reference the class of this, and then we run. Let's see if that passes. Oh, again. Sorry. This. No, that's wrong. You see it passes. Let's submit. As you can see, it's pretty much one of the fastest method other than one other option. And all of these run all one time complexity. And now I'll give you an example here of how this works. Is a bit more complicated. So let me show you on the whiteboard here. So let's say we have a stack, which is just of let's say 4, and a min stack of also 4. Now let's say we want to push 2. Now, so let's just push 2 to both. So now for the stack, the order doesn't matter, so we can just push 2 like that. But for the min stack, the order does matter, so we have to check, is the min stack length 0? It's not. And otherwise we check, is the current pushing number, so 2, is the value smaller than 4, which it is. So we push it 2 into the next min stack. Now that's easy because it's smaller, but what if the number is bigger? Let's say we push 5. Now again, for the stack, this is easy because the order doesn't really matter. So we push 5 at the end. But for the min stack, it has to be in order from largest to biggest. So we can't push 5 because it's bigger at the end. So what we do is we get the last smallest value and we push it. So we push 2, because it's smaller than 5, into the min stack. And the reason we do this is because then when we pop from 2, wait, before we do that, if we retrieve the last value of stack, we know it's 5, and the last value of min stack is 2. But if we push 5, we put it at the end, we know it would be incorrect. So, and if we pop, let's say pop 2, we'll always have the current smallest value at a time. So if we pop the last value, let's say we pop 2, 5, the last number, as you can see, is still 2 that's available in the stack and the min stack. So that's how we execute the push function. The rest are fairly explicit, so we need to implement the stack there. Here we obviously pop the last values from both, and here we return the last digit in stack and last digit in stack. Yeah, thanks for watching.